Hello, Johnny. We didn't actually videotape our class today because we didn't really teach any new, I didn't teach any new subject matter. We're still taking the volumes of revolutions with disks and washers, and we were revolving them around other lines. Now, the kids had trouble with the homework, so there was only those three problems, and I just set them up for them, so I didn't even tape it because it's kind of like just waiting for them to work things out and so forth. So I just show you the setup for each one in case you also had questions. So on 11C, what we did is we looked at a function y equals square root of x between y equals 0, x equals 3, and we revolved it around x equals 3. So that looks something like this. We have y equals square root of x, y equals 0, x equals 3, and we're going to take this area, just bound it by those three graphs, and revolve it around x equals 3. So here's our x equals 3. We revolve it around, so this area will show up over here from our viewpoint. And I'll put in a disk. Here's a typical disk that will help us with this problem. And that disk has a radius marked right there. So we learned to do this with pi r radius squared, and this one is, the thickness of it is in the y direction, so it's dy. And we're going to stack these pennies disks up from 3 to whatever this point is. So if you need to know this point, you put the x value in the original function and you get square root of 3. So we're going to stack these up from 0, y equals 0, to the square root of 3. And the radius is right here, and it's hooked to this point on the function. I'll call that point xy. And I notice that the x value is right here and the y value is right there. So if I want this radius, like right there, I notice it's related to this value for x, and the fact that this revolution, this is the axis of revolution, is at 3. So I can see that this value must be 3 minus this value. So I'm going to write that as 3 minus x. But because we want to work in y, I go back to the function and I see that x can be rewritten as y squared. So I'm going to rewrite my x in that way. So I have the integral from 0 to square root of 3 minus y squared, and that quantity is squared, dy. So we didn't work it out. You need to work it out for your assignment, but I just wanted it set up correctly and review in that way. So let's look at the next one. 11C, after that we did 12C, I believe. So moving right along. 12C is going to be, let me find mine. 12C. Y equals 2x squared, and y equals 0, x equals 2, around y equals 8. Alright, so I'm going to make my sketch. Hope this shows up good enough. I didn't set up my board, so hopefully it'll be helpful. We have a skinny parabola. The two skinny eyes is it. and we have y equals 0, x equals 2, and we're going to go around x equals 8. I'm sorry, y equals 8. So what's this point here? If x equals 2, plug that in the equation and we get 2 times 2 squared, or 8. So we have 2, 8 at this point. So it's at this point that we're going to revolve this. So it's going to come up here. Let me move my problem here, make room. So it's going to revolve around this line like that. And y equals 2, x squared was the problem. All right. So I'll put in one of my discs, and that's going to become a washer because there's a hole in this graph, so, or in this volume. So let's look at that one. We're going to go the integral of pi. These are going to stack up from here all the way over to here, so from 0 to 2. And now we want the outer radius minus the inner radius. So the radius is going to go from here to all the way down to here. And you can see it'll be the same all the way across. So we're going to go from the value of y equals 8 down to y equals 0 for every one of those outer discs. So that's a radius of 8. Now the inner radius, you can hardly see it, it goes from the center, which is y equals 8, to the function right there. And that function's value could be anywhere along here. So we know it is in the y direction, but it's not exactly y, because I'm going to put the point here, and that's my xy point. So I went over x and up y. So what would be this value if this is y and this is 8? I think you can see it's going to be 8 minus y quantity squared. But this is the thickness of each of these washers is in the x direction. So we're going to have to come back and mess with this y. So I'll do 64 minus 8 minus, instead of y, I have to rearrange this, and I get a value. Oh, no, I don't have to rearrange it. Y equals 2x squared, so I just put 2x squared there. So we have 8 minus 2x squared quantity squared. So you get to chug that all out between 0 and 2. So, all right, the last one we went over was 12D. Let's see if I can find it. 12D is y equals 2x squared again. That was the same one, same setup, I mean. Y equals 0, except we're going to go around x equals 2. So let's see if I can draw it a little clearer this time and still fit in the screen somewhat. All right, let's have 12D. What am I looking at? Okay, it will look quite a bit different, be easier to draw. So we had this value, the skinny parabola, the value x equals 2, and the x-axis, and it's going to go around x equals 2. So here's x equals 2. So it'll spin around that and sort of make like a witch's hat. All right, so we're going to notice that this point is 2 plugged into here, or 2, 8. See if that would be helpful. All right, so we don't need washers, so we need discs. So here's my one disc. And I'm going to hook it to the function at the point xy. Notice that point is x over and y up. And I don't hope this is showing up. Alright, so we set up the integral. Pi from 0 to 8, they're going to stack up. And the value for the radius, here is the radius, and it has something to do with the 2. From here to here is 2, and from here to here is the value x. So do you see this is 2 minus x. Quantity squared dy. And we want to work in y because the thickness of each of these discs is in the y direction. So we have to rearrange this for y. So we move the 2 over and take the square root of it. Oh, lovely. Okay. So I'm going to replace the x here. So I have pi 0 to 8, 2 minus square root of y over 2 quantity squared dy. Alright, so I actually did that out and it worked for me, so it can be done. So just setting it up. In addition, we talked about some of the other ones that were from the assignment before. That was before we were revolving around lines other than the x and y axis. No, we were revolving only around the x and y axis. So we took up some time with just individual questions and trying to work all these out. So we didn't cover anything new, and I did assign 3 more. So the 3 more that we're going to do are numbers 15, 20, and 21, and that is still on section 4.4. Do you have those? Do you have your book? Let me give you the problems. I know it was like a Thursday. I don't know if you took your book home on Thursday because you didn't have class, so I'll just give you the problems. Number 15. Whoops. I'll try to show you the problems. Let me get my book here. Number 15, we're going to take the area bounded by y equals x, y equals 3, x equals 0, and revolve it around the line y equals 4. So get that in there. So that's number 15. So find that volume. And then number 20 is y equals 5 minus x, y equals 0, y equals 4, x equals 0. All that, that's the area bounded by all that. And we're going to revolve it around the line x equals 5. So mess with that. And number 21. X equals y squared, and x equals 4. That's the area bounded by that. And we are going around the line x equals 5. Alright, so I hope you're not feeling too bad now and that you'll be well by Monday. And I hope that this was helpful, and I'm glad you didn't miss a whole lot. So we have a new topic to forge ahead with on Monday, so I'm counting on you to be there. Till then, bye-bye.